So let's take a look at what a list or a string might look like in memory. So for this example, we are going to use the letters in a string, although this would work just as well with the items in a list or in a tuple. And this is an abstract view of how it will work in memory, although it maps cleanly to how C will be storing its arrays, and same with Java and its elements in a list. So what we're going to do is that we're going to assume we have some kind of word. Let's go ahead and maybe, why not? Keep it like this. Let's suppose we have some word, right? And inside that word, we are going to store Python. So let's go ahead and make ourselves a little table for that. Let's make it about this size. Okay. Boop, 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 boop. Amazing how awesome and how bad that went. All right. So now let's go ahead and make some slots. 2, 3, 4, 5, 6. Okay, now what we can do is we will write in our letters P, Y, T, H, O, N. Okay, equals. Our word is equal to Python. It's storing this string in memory. Now, essentially, a string is made up of individual letters or glyphs, right? Because it could be other symbols. And they're stored in a string together. This is known. And we know this is in a string because it's in between quotation marks. Now, each individual glyph or letter is going to be given an index. It can be referred to by an index. 0, 1, 2, 3, 4, 5. And this allows us to access any individual letter inside this string. So, for instance, if I were going to ask the compiler or the interpreter, what word, what word at index 2 was, and that's how we write that out, word open bracket to close bracket, it would tell me T. If I were to ask it for the glyph or letter at index 3, it would give me H. If I were to ask it for what was at index 0, it'll give me P. At index 1, it's going to give me Y. At index 5, what is it going to give me? That's right, it's going to give me N. What if I ask for the letter that's at index 12? What should that be? And the answer is nothing. It's going to give me an error. It's going to crash my program, which is all sorts of niceness. So my word is stored as Python, and each letter can be accessed individually. This works just as well for a list of stuff. So, for instance, if I had, say, a bunch of items, let's go ahead and actually call our list, let's call it my stuff. And I were to say it's equal to, and I'll just use our standard words, apple, banana, and I'll go with bread because that's short and easy to write, right? In memory, it would look like this. It would look something along the lines of this. So let's go ahead and slice. You can do it. There we go. A-P-P-L-E, B-A-N-A-N-A, and bread. So that would be at index 0, index 1, and index 2. Now, the reason why... Now, if I were to ask you for what's at index 0, I'd say I would get apple back. Index 1 would give me banana. Index 2 would give me bread. Now, it wouldn't give me A back if I asked for 0, because this is a list, as denoted by these very awesome brackets. Now, it is a list of things, specifically strings in this case, so whatever item is in the box, I will get back. And how do I know what's in the box? It's separated by commas. So apple is at index 0. 1 gives me banana. 2 gives me bread. Now, this notation is actually reminiscent of a mathematical notation, right? So let's go ahead and look at, go back to a different list. So let's go ahead and take a look at vector. So I've got a vector equal to, let's say 12, 7, and -3, right? So this is some kind of vector, right? And if I wanted to get the, and in math you might start at 1, but we're going to keep starting at 0. So if I wanted to get the first vector, or actually the 0th vector, or sorry, the 0th item, if I wanted to get this guy, right, and this vector was instead, and in math, of course, you don't use a handy-dandy word. You use a single annoying letter. So let's go with capital A. If I wanted to get a single item from that, I would say basically A0, and that would correspond with 12. And A1 would correspond with 7. And A-3 would correspond with A2 would correspond with -3, right? If I gave you this, you might go, oh, so that is 9, right? Because it's it's the second item of an A squared, right? Really annoying mixing these subscripts and superscripts notations. Fortunately or unfortunately, that is not something you can do on a computer, right? Similarly, if we wanted to write some number, say x squared, we don't write it x squared on our computer, right? We write it, at least in Python, as x ** 2. And you'll have to forgive my handwriting. I should have been a medical doctor, I know. But so similarly for this kind of thing, we don't have a subscript. Instead, we imitate it by using brackets. So we are going to see this now in a more typewritten, easy to read format. But this is if I were to ask for the computer to print out A of 1, it would print out 7, because this is at index 0, 1, and 2. Actually, 0, 1, 2. All right, so let's go ahead and move over into our next video and just give this a more, and let's see what this looks like in Python.